part of our mini-series on conics. Today our focus is on circles. So I have the definition up here. A circle is a set of all points in a plane that are a given distance. We generally call this distance the radius from a given point, which we generally call this the center. So let's take a look at what a circle would be. If I draw any arbitrary point right here, I'm going to call this my center. Now, it's going to be of equal distance. So if I pick some distance, and the distance doesn't matter, so let's call this my distance, which means this would be my r. And generally we denote the radius. We use a lowercase r to denote this. So if I call this the radius of r, then this is my set distance. So this point right here, and notice that it's only the point, so only the red points are going to be part of the circle. And in fact, even the center is not part of the circle, because the center is not a given distance from the given point. If I let this be my center right here, the center is actually zero distance from the center because it is the center. So I've got no distance there. And if I pick, say, this point right here, well, that would have some distance from the center, but it's not a distance of r. So that point would not be on the circle either. But if I go in any direction of this, from this point here, I'm going to have a set distance from this spot. So if I choose to go in this direction, well, somewhere up here, I'm going to have a point that is in this circle because that is a given distance away. And no matter what angle I pick, let's say I pick this angle, and in fact there's infinitely many points in the set, but it's a set of all points that are of equal distance away. So wherever I go, and if I go down here, this would still be r. As long as this distance is r, then I've got a set of all points that are of equal distance away. I'm going to try to make this even as best as I can. But imagine that this spot is even. Anywhere I go, this spot would be r, and this spot would be r. Looks like I'm off a little bit, but each one of these spots are an equal distance away. So anything that's on that red is going to be a point in the circle. And if we get rid of this stuff in the middle, that's generally what we would think of as a circle. It's this round, circular shape. But from the definition, we know that each one of these points is of equal distance away from a given point, which is right there at my center. Now the center, again, is not part of the circle. So how would we come up with an equation to write this? Well, we go to the definition. If I pick some point, and let's call this my center, and in fact, let's put this on the x and y axis. Let's put this on the Cartesian plane. So right here, and the distance is not important, so we're going to leave the distance at r. So the center right here, I've set this equal to the origin, so this is the point 0, 0. What that means is it's 0 on the x and 0 on the y. And I want the set of all points that are of equal distance. That means it's the set x comma y such that the distance from 0, 0 to x comma y is equal to r. Now we could write that in set notation, but I don't want notation to distract us from what we're talking about. So we're just going to stick with our definition that we have. And let's use blue to show if I'm going to go from here to here, whatever this distance is, we'll call it r. That's got to be the same distance as from here to here. This has got to be r, and that's going to be the same distance everywhere. So let's say that. But let's get a little bit more specific with what we're saying. So if I take this point right here, and let's call this point x1, y1. So it's just some collection of x1, y1. That's got to be some distance away from the origin. And let's call this x2, y2. And that's got to be some distance away from the origin. And let's see what we come up with. Well, if you recall, if I'm using the distance away from there, I've got a formula for that. It's the distance formula. And the distance formula is d is equal to the square root of delta x squared plus delta y squared. Now, what is delta x and delta y? Delta x means the change in x. It's how am I changing from one point to the other on the x-axis. And the delta y is how am I changing from one point to the other. So if I drop a perpendicular line right here, this would be coming straight down, I would have a right angle. So circles actually have a lot to do with triangles, and we can see that in trig, which is a study of triangles. It's actually quite a unique relationship to this circle. Here. And let's drop a perpendicular right there. There's that triangle. Well, delta x is the distance from the point that I'm looking at, so I'm looking at 0, 0, to this point right here. So to this here, this distance, this is going to be delta x. And then from the point that I'm looking at here to here, this is going to be delta y. And we can see that, well, if that's set up a right triangle, I can see that r has got to be equal to, by a Pythagorean theorem, r squared is equal to delta x squared plus delta y squared. And we can see, well, that's a squared plus b squared is c squared. If you haven't seen the Pythagorean theorem before, it's actually really cool. I'll go check it out. There's a lot of proofs out there that show that this, I'm not just taking this, it is actually a true theorem. So we've got r squared is equal to delta x squared plus delta y squared. But what's r? That means r would be the square root of that. Well, it would be the square root of delta x squared plus delta y squared. Right there. Now, r is the said distance away from the set point. So we use d here. D is a generic distance. But in this case, I'm talking about the distance from this point to this point. Well, that is r. So r is, in fact, the distance. So whether I use d or whether I use r in this case, it shows the same thing because it's the distance from the center to the circle, to that set of points. Well, let's do this in general now. If I look at what is this distance here, what is delta x? Well, the delta is defined as my current minus my previous. So if I'm going from 0, 0 to x1, well, this distance here would actually just be x1 minus 0. So we can see, well, that's just x1. And likewise, if I'm going from 0 to y1, this would be my current minus my previous, or y1 minus 0. So that would be a distance of y1. So we'd have, in this case, delta x is equal to x1, and delta y is equal to y1. So we would get r is equal to the square root of x1 minus 0 squared plus y1 minus 0 squared. And that is the same as saying r squared is equal to the square root of x1 squared plus y1 squared. Now, if I want to get rid of this square root, the common thing is we square both sides, and we'd say, well, if I square this, you would have r squared is equal to x squared plus y squared, and it's very common to write this as x squared plus y squared is equal to r squared. Now, I use this subscript just to say that it's a specific point, but really any point on the circle would work for that. So if I do the same thing with my point over here, just to say, well, it's still going to work for that point because the definition of this point is going to be, well, it's the same definition. It's going to be the distance from my center to my point over here. So I'm looking for this r. Now this r is the same distance, but what's this point? Well, it's going to be x2 minus 0, and this is going to be y2 minus 0. So I'm going to have r is equal to the square root of delta x minus delta y, which is going to be x2 minus 0 squared plus y2 minus 0 squared. And that's the same thing as the square root of x2 squared plus y2 squared. And if I square both sides, I'm going to get r is equal to x2 squared plus y2 squared. And in fact, if I picked any point, if I picked this point and I call this xn, yn, and I do the same thing, you would get r is equal to xn squared plus yn squared by the same argument. Because if I take that from 0, 0, I would have that general distance. So in general, we just let xy be any point on that circle. So if I wrote in set notation, I would actually write it using xy, and xy is any point on that given circle. So let's just take this point to be that point on the given circle, but it's a generic point, so I can use it for anything. And then, well, I get my general form. I get x squared plus y squared is equal to r squared. Now you may have seen this before. This is the standard equation of a circle. Now do note that the coefficients here of the x and the y, these are both the same. So if I expand this, if it's 0, 0, then it's at the origin. But what if it's not 0, 0? We're going to look at that in the next video. But I'm going to expand this just generally to be ax squared plus ay squared is equal to r squared, where a is any real number. And generally we let a be positive. Actually, we'll let a be positive. But in this case, a is 1. So 1x squared plus 1y squared is equal to r squared. Just generalize it. I don't need that to be 1, but I do need it to be the same as the y. Okay, so we are going to do more with the generalization in the next video. See you guys next time.